So welcome to lesson 5.4, applying asymmetric encryption. We're going to put asymmetric encryption to work. So as a reminder, asymmetric encryption uses two keys. We call that a key pair. One side locks, the other unlocks for encryption and decryption. Those are two different but mathematically related keys, and we're going to refer to them as the public key and the private key. Now the public key is widely distributed. So every user or every system has two keys that are going to use asymmetric. The public key, we want it out in the public. We want everybody to have the copy of the public key. But the corresponding private key must be protected. So in talking about key pair security, public key widely distributed, corresponding key has to be secured. So let's look at our key pairs in action for encryption. Alice has a public and private key pair. Now she freely distributes her public key and she securely stores her private key. So she's the only one that has her private key. Bob wants to send Alice an encrypted message. Bob wants to make sure that whatever he sends, that only Alice can decrypt it. So Bob obtains a copy of Alice's public key, and Bob encrypts the message with Alice's public key. Why does he do that? Because the only key that can be used to decrypt the message will be Alice's private key, and only Alice has a copy of her private key. So let's look at that in a message flow. We've got Bob and Alice. Bob has a plain text message that he wants to send to Alice. He's going to take an asymmetric cipher plus Alice's public key, because it's a key that freely gets distributed, and from that he's going to end up with an encrypted message. Then Alice is going to use the same asymmetric cipher and her private key, because her private key is the corresponding and mathematically related key to the key that Bob used when he used her public key to encrypt the message. So she's going to use her private key and end up with the plain text message. Simple enough. The key to always remember is that you are going to encrypt using the public key corresponding to the private key of whoever owns that key. In this case, that was Alice. But in reality, the message isn't going to flow like that. We're going to use a hybrid method. And that's because asymmetric cryptography is pretty resource intensive. So in most message flows, we're going to use some combination of both symmetric and asymmetric. So let's look at a hybrid. Bob's got a message he wants to send to Alice. It's a plain text message. What Bob's going to do is he's going to use a symmetric cipher and a shared key. But that key is only going to be used for that session, so it's going to be referred to as a session key. He will then use the symmetric cipher and the session key, perhaps AES, and end up with an encrypted message. Only way that Alice is going to be able to decrypt that message is to use that same session key and that same symmetric cipher. And if she does that, well, she'll have the plain text. But the problem there is that we had to find a way to get her the session key. But because it's a message and it's a block, we really want to use symmetric encryption because it's going to be much more efficient. So now our challenge is, how do we get the session key over to Alice? And asymmetric encryption is what we're going to do with the session key. So Bob's going to take that session key, he's going to use an asymmetric cipher, and he's going to use Alice's public key, because he only wants Alice to be able to get that session key. He's going to have an encrypted session key that'll get sent to Alice. Alice will take an asymmetric cipher and her private key, and now she's going to have the session key. And if you pop back up to the top line, she can now take that decrypted session key, she can use it with a symmetric cipher, and she can decrypt the message that Bob sent her. So in reality, we're tending to use both symmetric and asymmetric together in a message flow. So let's look at a case study for encrypting messages. Bob is our procurement officer at Anytime Medical Supply, and he wants to make sure that all the messages between him and Mary, his Anytime Hospital counterpart, are encrypted. Because the messages are large, they're going to be encrypting the messages using a symmetric algorithm and a shared session key. But Bob's really confused as to how to get the session key to Mary, and he's asked you for instructions. Well, I suppose one option would be that he goes and sees Mary and she actually shares the session key. But assuming that they're not in the same place, she's at Anytime Hospital, he's at Anytime Medical Supply, he needs a good way to get that key to Mary. So let's see what he's going to do. Well, Bob needs to obtain Mary's public key. Mary's public key will be used to encrypt the session key, and the corresponding key, Mary's private key, will be used to decrypt the session key. And then the session key will be used to decrypt the original message. So Bob is going to use our hybrid methodology. So let's see what you have to know. Required knowledge. You need to understand the function of a key pair, that they are mathematically related, and what a private key and public key does. And then you need to recognize public key distribution, the fact that the public key can be widely distributed, and private key security, that we have to keep our private key secure, because that's the way we ensure that only the holder of the private key could be able to decrypt that particular message. That's what you need to know.